All right. Hello, hello, hello. Good afternoon. Welcome back to Math 161. And in case you haven't seen it yet, we did start 2.3. We completed example 1. There were a couple other problems besides just this A. There were a B and a C. We discussed the point slope form for the equation of a line, how if we give you the slope and a point that it goes through, you can just put those three numbers into this equation. And then we started example 2a. We said to find the equation of a line going through 2, 3 with a slope of 5 and graph it. We did not graph it yet, and I'm just going to start this one from scratch. So let's pull up our whiteboard. All right, so example 2a. Sorry, I got to move a couple things around. Just give me a second. All right, so we had the point 2, 3 with a slope of 5, and this is just review. Y minus the y1 was the 3 equals the m, which was 5, parentheses, and then the x minus 2. And then when we distributed the 5, we got y minus 3 equals 5x minus 10. Then we added 3 on both sides to get, I'm just going to keep the color the same this time, to get the y equals 5x minus 7. And now we need to graph this. Well, before we do that, I want to mention that there are two ways you can do this. You can use the point they gave you, this 2, 3, that's one point, and then you can just find a second point by plugging in x equals 0, x equals 1, or 2, or any number that you want to find the y value, and there's your point. And then you could just plot those 2 points and go from there. However, I want to go over a slightly different way, if it'll let me type. There we go. Given the slope as a fraction, slope is rise over run. The run, i.e. the bottom, tells you how far to go right. The rise, in other words, the top, tells you how far to go up or down based on the sign. So slope as a fraction is rise over run. If you have a point, you can always find another one by going right based on the denominator's number and then up or down based on the numerator's number. Please notice that I never used the word left. We're not going to use slope to go left to find a second point. I'm not saying you can't, I'm saying we won't, because everything's backwards when you go left. So if you want to use this strategy for finding a second point, you're always going right based on the denominator and then up or down based on the numerator and its sign. But you have to have that slope as a fraction, which this original problem did not give it as a fraction. So we are going to need to write it that way. What just happened? There we go. So we had a slope. Sorry, this is being weird. We had a slope of 5, which we can rewrite as 5 over 1. Now again, the denominator tells you how far to go right. So we'll go right 1. And the numerator tells you how far to go up or down. Since it's positive, we'll be going up. Now you can go up 5 and then right 1, or right 1 and then up 5. The order that you do those doesn't matter, as long as the denominator is telling you what you go right and the numerator is telling you the up or down. If you swap, if you go right 5 and up 1, this would not be the same relationship. So what I'm going to do is I'm going to plot this 2, 3 first, and then I'm going to use the slope to find the second point. So let's go over here, and we're going to need a big section of the positives. So let's just do this. All right, so we got the point 2 comma 3, that's right 2 and up 3. 1, 2, 1, 2, 3. So there's the first point. That point was given to us. And if you don't trust that that point's on the line, if you plug in x equals 2 here, 5 times 2 is going to be 10. 10 minus 7 is 3. So that point is valid. But now I'm going to use this idea of slope, and you're going from this first point. We're not going to go back to the origin and go right 1 up 5. We stay at this point and we go right 1 and up 5. And then we could find a third point by going right 1 and up 5. And then we could find another point by going right 1 and up 5. We can do this over and over and over. So we're going to go right 1, and I'm going to go ahead and set up some extra numbers. 3, 4, 5, 6, 7, 8, 9, 10. So we're going to go right 1. This is the run. And then we're going to rise 5. 4, 5, 6, 7, 8. So we went right 1 and up 5. And then that will give us our second point. Again, we went right 1 from an x value of 2 to 3, and we went up 5 from a y value of 3 to 8. That is at 8. I know I got a little squish there. And then we just connect and extend to make our line. I'm going to do the best I can with this tablet. Please forgive me if it goes crooked at any point. And there's our line. Now again, I did not have to find that second point based on this method. I could have just plug in x equals 0 or x equals 3. Even if you plug in x equals 3, I said you can use 0, 1, or 2, but you can also use 3. You get y equals 5 times 3 minus 7, which is 15, minus 7, which is 8, giving us the coordinate 3, 8, which is exactly where we ended up. And again, you don't have to use exactly these 2 points. You could have plugged in x equals 0, and you'd end up with -7 for the y value, so that point would be 0, -7. You could plug in 1, and you'd get -2 for the y value, so 0, -7, and 1, -2 would form that line. They'd be plotted down here instead, but when you extend that line infinitely, it will still form exactly the same line. So I'm a big fan, excuse me, of using the slope method for graphing points. No, it is not always 0 through 3. You can literally use any number you want. If you want to use 5.793 and plug that in as x, then you can find the y value. You have unlimited options. I just like to keep my numbers small. Good question. All right, so let's go back to our screen. And I had some instructions on here as well. This is the same thing as what we saw on the whiteboard. Plot the point first, then use the slope as rise over run to find the second point, which means go right based on the run and up or down based on the rise. And again, that was optional, but I do prefer that method. So for B, the ... is just saying find the equation of a line going through. So ... find the equation of the line going through the points -1, 0 and 4, 5. So -1, 0 and 4, 5. This is a slightly different problem than the last one. In the previous example, I gave you the point 2, 3 and a slope of 5. I gave you a point and a slope, and we were able to just directly insert that into point slope form. Again, we call it point slope form because you plug in a point and a slope to get the equation. That is not the information that's been given this time. I gave you 2 points. So if I have 2 points, you can't plug them into the x1, y1, the x and the y. I'm going to argue you can, but I'm saying that's not how we normally do it because you need the m. How do we find the m if we're just given 2 points? Well, last time we gave you the equation, and I'm just going to scribble it up here for a second. We had the m was y2 minus y1 over x2 minus x1. That's our slope formula that we said you have to memorize. It's never going away, just like a lot of things in our algebra classes. So we'll have to use that first. And that's exactly what we have here. Just a extra little memo. Find the slope first if you're given 2 points. So we'll use that equation to find the slope. All right, whiteboard. Next example. This will be B, example 2B. So those points were, again, -1, 0, and that's an ampersand, 4, 5. All right, so we're going to use that slope equation. And if you need to label things, the -1 is the x1, the 0 is the y1, the 4 the x2, and the 5 is the y2. So therefore our slope is going to be y2 minus y1, that's 5 minus 0, over. And then x2 minus x1 is 4 minus -1. This is something to watch out for. Those double negatives. A lot of people will just say 4 minus 1 because they see this minus and think it's part of the subtraction. So this is really 5 minus 0 over 4 plus 1, which is 5 over 5, and that's 1. So our slope this time is 1. Okay, so now we want to find our equation and then ultimately graph it, same instructions as A. But now we have too much information. We have the slope, we have a point, and we have a second point. But we're supposed to be plugging this into y minus y1 equals m times x minus x1. What do we do with the x2s and the y2s? Well, simply put, you can ignore them. In fact, you have a choice. You can either use the 4, 5, or you can use the -1, 0. And I'm actually going to show you both ways and how they look different initially, but if you solve for y, they end up being the same. So let's say version 1. This is where we're going to use the -1 and the 0. So we'll go y minus the y1, which is 0, equals the m, which is 1, times x minus x1, that double negative again. So that's y equals, y minus 0 is y. That's 1 times x plus 1. Distributing 1 does nothing, so that's y equals x plus 1. And that would be our equation. In a different color, I'll do another version. Let's do this in green. So version 2. That would be y minus, now we're going to use the 4 and the 5 instead. So y minus 5 equals the m, which is still 1, that stays the same, then x minus the x coordinate, which was 4. Distributing 1 does nothing, so that's y minus 5 equals x minus 4. And then if you go and add 5 to both sides, oops, wrong color. You get y, come on, equals x plus 1. Look at that, the same equation. It's interesting because when you plug the point in with the slope, initially they look different. But when you solve them for y, which is a very, very critical form of equations that we'll get into next, when you solve them for y, they end up being identical. And that's why these are the best format, because you can clearly compare them. You can't necessarily compare them at the beginning, but here you can. All right. Now, to graph this time, I'm not going to use the slope. Just use the original points. They gave you 2 points. Why not just plot with those 2 points? Because if you go and plug x values into these equations to get your y values, hopefully you'll get them right. But if you get them wrong, you're then going to have a bad graph, even though you've done everything else incorrectly. So whenever you're given 2 points, it's my suggestion, just go ahead and use those for your graph. Now, if you want to plug in x equals 0 and x equals 1, find y values and plot those 2 points, that's fine. If you just want to use one of these points and then the slope, which is 1 over 1, you go right 1 and up 1, that'd get you your second point, and that would be fine. There's literally infinitely ways to graph this line. So I'm not going to stress any particular method. All right. So we got -1, 0, so that's left 1, up or down nothing. So there's our first point. And then 4, 5 is going to be right 4. 1, 2, 3, 4. I'm just going to label the 4. And then up 5, 1, 2, 3, 4, 5. And again, I'm just going to label the 5. So right 4, up 5. Looks like about right there. Connect the line, connect the dots to make your line. And make sure you're extending past the dots. If you just connect the dots, that would only be a line segment. It is not until you have arrows on the ends and you're going past the points that it is a line. It's not the best looking arrow at the top. There we go, a little better. So there's our line. And again, there are so many different ways to have graphed that line. It is uncountable. There are infinitely many ways to have graphed it. But it's only a couple of methods. It's just a matter of what particular points you use. All right. Okay. So let's move on to the next bit in the notes. Come on. Let's just do here. There we go. So we're down here now. So we've talked about point slope form a couple of times now. Why do we call it point slope form? Because in order to use it, you need a point and a slope. Or if you're looking at it, then you can tell a point it goes through and its slope. Well, slope-intercept form is the second useful form, and I don't want to say it's more useful. I don't want to say it's less useful. They both have their uses. Given a slope and a y-intercept. Now remember, intercepts always have a coordinate of 0. And remember that x-intercepts are always 0 comma something. This is being weird. Sorry about that. Remember that x-intercepts are always going to be something comma 0. So I'm just going to write a little question mark. And then y-intercepts are always something, 0 comma something. And the question marks are just saying it's a number. An x-intercept always has a y value of 0 because its height has to be 0 to cross the x-axis. A y-intercept always has an x value of 0 because in order to cross the y-axis, you have to go left or right 0. So let's just say we had a line here. That point right there would be the x-intercept. This point over here would be the y-intercept. Okay, so slope-intercept form, given a slope of m and a y-intercept of 0 comma b. So it's 0 comma a number, and that number we're going to call b. Why b? I can't exactly tell you why. It's just a letter that they decided to use. The form is y equals mx plus b. Y equals mx plus b. So the slope ends up going in front of the x, and then the y value, the y coordinate of the y-intercept is going to be plus or minus a number at the end, plus if it's positive, minus if it's negative. Now, since this is y equals, that means to get slope-intercept form, all you have to do is solve it for y, and guess what? We have already been practicing that. We did that in example 2a and b. So there's actually nothing new to get this format. You just solve it for y, but now we're able to say something else about it. Looking at that format, we can say its slope. We can also say another point that it goes through, particularly its y-intercept. Never an x-intercept. I'm going to say it again. Never an x-intercept. I'm going to say it one more time. Never an x-intercept. It's always the y-intercept. And if you don't trust this, if you plug 0 into this form, wrong thing. If you plug in 0, you get y equals m times 0 plus b. which is y equals b. So when you plug in 0, you get b. That's the y-intercept. Okay. So let's try out example 3. And there's an a and a b. For a, we're going to go through the point 3 comma negative 1 with a slope of 2. And I've specified this time to write it in slope-intercept form. Again, even though we've already been doing that, now I'm just being a little more specific. So when I say to write it in slope-intercept form, that means to do what? Solve it for y. And after that, we want to graph it, of course. We want to get as much practice at first with this as we can. So our point is 3 comma negative 1, and our slope is 2. Sorry, I keep looking at b. It's throwing me off. All right, so let's go back to our whiteboard. Let's go back to our whiteboard, please. Thank you. All right, so example 3a, we're going through the point 3 comma negative 1 and with a slope of 2. Now, you still want to plug this information into point slope form to make this as easy as possible. PS means point slope form, the y minus y1 equals m times x minus x1. Okay, so we're going to go y minus, the y1 is negative 1, equals the m, which is 2, parentheses, and then x minus x1 would be x minus 3. And from here, we just solve for y. Again, it's the same thing we were doing last time. This is y plus 1 on the left. Let's go ahead and distribute the 2. We can knock 2 things out at once here. So that's 2x minus 6. Then to finish this, we're going to subtract 1 on both sides. To give us y equals 2x minus 7. Okay, so again, we had a point and a slope, so we put that information into the point slope form, where the 3 was the x1 and the negative 1 was the y1. We cleaned it up, we solved it for y, and that gave us our answer in slope-intercept form. So looking at this, looking at y equals, if I asked you to identify the information that's identifiable based on it, the number in front of the x is your slope. So m is 2, which is a good thing because that's what we said in the beginning. That agrees with it. And then this number after it is a minus 7, that's the b, and you take on its sign for the b. Now, if b is negative 7, that means that we're going through the point 0, comma, negative 7. In other words, the y-intercept is 0, comma, negative 7. Now, there are a couple of different ways that you can graph this, surprise, surprise. We actually have 2 points now if we realize the y-intercept. So you could just plot 3, comma, negative 1 and 0, comma, negative 7, connect them and extend them, and that would give you your line. And that's perfectly fine. It'll get you full credit all day long. But I want to practice using the slope one more time to get a second point. So let's just go with the original information again. This is a method in case we messed up anything down here, because if this equation's wrong, then the y-intercept's wrong, and now we're going to get both the equation and the graph wrong. So if we can keep the graph separate, why not? So let's just use the point and the slope. Now, in particular, with an m of 2, that means it's 2 over 1. Its rise is 2, its run is 1. So we're going to go right 1 and up 2 from any point that we plot to find another point. Okay, so 3, comma, negative 1, that's right 3, down 1, So there is our first point, a point that was prescribed before we did anything. And then from that point, we can use the slope. And I'm going to put a couple other hash marks up here for 5, 6. I'm just going to label every 3 on that. And then for the y-axis, let's go 1, 2, 3, 4, 5. So with a slope of 2 over 1, we're going to go right 2, excuse me, right 1. Something just popped up on my screen, sorry. How do I make this go away? Okay, sorry about that. So we're going to go right 1 from 3 to 4, and then we're going to go up 2 from a height of -1. We get to 0, and that's 1, and then we get to 1, and that's 2. So from -1 going up 2 puts us at a height of +1. So we went right 1, up 2. I'm using the colors to illustrate the run and the rise. And then we'll have our second point over here. In particular, that point is 4, 1. If you wanted to label it somewhere, you can. That's that point. I just want to make sure I've got enough room. And then you connect and extend. So we're going to go like this. And how far you extend it on paper doesn't technically matter as long as you go past the points and put the arrows. If you might, maybe you want to hit the intercept. Maybe you don't. That's up to you, but this is good enough. So again, that point right there is 4, 1. This point down here was the 3, -1. And again, if you had used 3, -1 and 0, -7, you would have plotted this point here, and then 0, -7 would have been down, roughly about here. And then when you connect them, you can see that you would still form the same line. So we took our point and slope, plugged it into point slope form, solved it for y to get slope-intercept form. I identified the information for good practice, but then I didn't even use it. Again, that's up to you. You can use it or you can not. All right, let's do another one of these. And then share screen. So for B, we said we're going to go through the point -1, -5 with a slope of -3. So finally a negative slope for the graphing. I wanted to make sure we got one of those. So again, the point's -1, -5, and the slope is -3. So B, the point -1, -5, and a slope of -3. Now, this is going to flow just like the last example. We're going to put this information into point slope form. If you need to write down what things are, the -1 is the x1, the -5 is the y1. So that's the y minus y1 equals m parentheses x minus x1. So we go y minus, that's a negative, so watch out, -5 equals the m, which is -3, open a parentheses, x, excuse me there, x minus, and then the x1 was a -1. Again, be careful because of the negatives. And then let's just clean this up and solve it for y. So the double negative on the left makes a plus, so y plus 5 equals -3 parentheses, double negative, so that's x plus 1. Let's distribute the -3, so we'll get y plus 5 equals -3x. Be careful, minus 3, -3 times +1 is -3. And now we're going to need to move the 5 over. So we subtract 5 on both sides. If that had been a y minus 5, we'd be adding 5 to both sides. So those 5's cancel. We get y equals, leave the -3x alone. -3 minus 5 will give us -8. It's solved for y, which means it's in slope-intercept form. Again, how do we tell something is in slope-intercept form? It's solved for y. So if you wanted to identify the important information from this, m is still -3, thankfully. That tells us that the b is -8. B can certainly be positive. It's just a coincidence. There's 2 examples in a row it's negative. So that means the y-intercept is 0, -8. Now this time, I'm going to, sorry if you heard that, the joys of teaching at home, everyone. Just someone at the doorbell. All right, so with a slope of -3 and a y-intercept of 0, -8, again, the slope agrees. We also have this point up here, -1, -5. Now I could do the same thing as last time. I could plot the -1, -5. I could use a slope of -3 to go right 1 and then down 3. Or alternatively, I can plot the 2 points given. For one last practice, I'm going to use the slope. I keep accidentally hitting this. The struggle is real. So with a slope of -3, which is -3/1, that says we're going right 1, but since this is negative, we'd be going down 3. So our rise is more like a fall, if you will. All right, so -1, -5. Gonna need a little more of a bottom heavy one here. So -1, -5, that's left 1 and down 1, 2, 3, 4, 5. So here's a height of -5, here's left 1. Boom, there's our first point. That's the -1, -5. Now again, you could go ahead and plot 0, -8, connect and extend, and that would be fine. I just want to practice this slope use again. So let me put a couple more hash marks up here, -6, -7, -8, -9. I'll go down to -10. So we're going to go right 1. So from the point we first plotted, I'm going right 1. Now starting at -1, going right 1 puts us at 0. Then we are going to go down 3 because of the -3, not up 3, down 3. So 1, 2, 3. So that puts our point right there. And you may notice that that point is 0, -8. So it's a coincidence. We actually ended up picking the y-intercept, and that's because the first point we plotted was basically next to it. So that really confirms that everything is accurate. And then we just connect and extend them. So I'm going to extend this one as far as I can this time. Maybe about here. That's going to be bad. Okay. That's just a little off there, but you get the idea. This drawing tablet, I'm still getting used to it. I'm getting better. And I didn't exactly have the best drawing capabilities to begin with. So again, this is how we put things in slope-intercept form, given a point and a slope, or just 2 points. Examples 2 and 3 both illustrate that. We've also illustrated how to graph in several different ways. Use what you prefer. Okay. Moving on. Graphing using intercepts. Graphing using intercepts is extremely helpful when you're in something called standard form. And you're not even going to see me have standard form written in these notes anywhere because it doesn't tell us any information. I'm going to scribble it to the side right now. But again, it's kind of a weird one. Standard form. Of a line. Looks like this. AX plus BY equals C, where A, B, and C are integers. Whoop-de-doo. How is that useful? How does that tell us anything about the graph of a line? It doesn't tell us a slope. It doesn't tell us an intercept. It doesn't tell us a point. The only thing it does for us is sit there and look pretty. We don't want to have any fractions in this form. We want the variables on one side and the constant on the other. Now, I'm not saying that this form isn't useful in some ways. When we do systems of equations, this is usually a really good format to be in for certain methods, like if you were to use matrices or if you were to use elimination, also known as the addition method. So it has its uses, but in terms of graphing lines, which is the main emphasis for now, there is no use to this. It doesn't tell you any information. But you still might be given an equation in this form, and you can still graph it in this form. You can still find different x and y coordinates. And one of the best methods is right here, graphing using intercepts. Because intercepts, you're just plugging in zeros. One time you'd let the x be 0, one time you'd let the y be 0. Zeros are easy to plug in this format because it's going to make most of the jazz just go away. So me in particular, when I get a line that's in standard form, almost every time I'm going to graph that by using the intercepts, by plugging in x equals 0 and then plugging y equals 0. Does it mean I have to do it that way? Absolutely not. I'm just giving best practices. You could still take that equation and solve it for y, and then you can see its slope and an intercept. You might be able to magically transform that into some type of point slope form, and we're not going to get into that because I really wouldn't want you to do that. There's honestly no reason to. Okay, so let's clear our screen. Oops. All right. So for example, 4, and we're just going to do one of these. This is not an A and a B. This is just example 4. Graph using intercepts 4x minus 5y is equal to 40. So that's in standard form. That's the thing I just mentioned. It doesn't tell us anything useful. I can't look at that and tell you what its slope is. I can't look at that and tell you what its intercept is. I can't look at that and tell you any points it goes through. But I can still graph it, and it's the easiest way would be to use intercepts. If you want to plug x equals 0 and then x equals 1 and find y values, again, you're more than welcome to. Occasionally, you're going to have issues with fractions being in there, which might just annoy you, but you know, it still works. All right, whiteboard. Example 4. This was graph 4x minus 5y is equal to 40, I believe. So here's what I like to do. I like to start with this, with a table of values, where one time the x is 0 and one time the y is 0. That is the intercept method for graphing because I'm just plugging in zeros, one time x, one time y. Do not sit these next to each other. Please do not sit these next to each other because that would be you implying they're going through the origin, and we don't know that. All right, so when we plug x equals 0 in, we'll get 4 times 0 minus 5y is equal to 40. 4 times 0 is 0, so that's just negative 5y equals 40. We can solve this by dividing both sides by, that was weird, negative 5. And that tells us that y is equal to negative 8. And I'm gonna redo the table just over here in the hopes that maybe you do as well. So now we know that point is 0, negative 8. All right, let's try y equals 0. So that would be, now we're restarting. We're not plugging it into 4 times 0 minus 5y. We're going back to 4x minus 5y equals 40. So that's 4x minus 5 times 0 is equal to 40. The 5 times 0 is 0. Again, this is why we like the intercept method. It makes things go away really quickly in this format. So we get 4x equals 40. You're going to divide both sides by 4. And that's going to give us x equals 10. So our points are 0, negative 8, and 10, 0. Notice this is not the point 10, negative 8. That's one of the most common mistakes I see made. is that people ignore the zeros and just combine those two numbers somehow. But no, these are two unique points. So X, Y. I'm not even going to put a whole bunch of hash marks up on this thing. I'm just going to label two different numbers. There's a 10 in the X column, which means somewhere I need a 10 on the X axis. Not over here, not on the left, that would be a negative 10. And there's a negative 8 in the Y column. So that means I need a negative 8 on the Y axis, not on the top, on the bottom. Those are the only two hash marks I'm going to have to label by hand. That's exactly where the points are going to end up. And if you don't believe me, 0, negative 8, start at the origin. You're going to move left to right 0 and down 1, 2, 3, 4, 5, 6, 7, 8 times. There's our point. 10, 0, you start at the origin. You go right 10 and up or down nothing. There's our point. Another benefit to the intercept method is that your points end up on the axes, so they're a little easier to draw by hand, especially if you are not the best artist like your teacher. Then we connect them and extend them. Sorry about that little impulse there. I'm not going to erase it and start over. Let's just do this. There we go. Put a Band-Aid on it. So that is our line. Again, did I have to graph this problem that way? No. All I said was graph. I could have solved this for y, found the slope in the y-intercept. In fact, the y-intercept would have been right here. We end up finding that. That's 0, negative 8. And your slope for this ends up being, what is that, 4/5? Yeah, if you solved it, you would determine that the slope is 4/5, which means you would go right 5 and up 4. And if you did that twice, you would actually end up here. So if you went right 5 and up 4, you'd end up at 5, negative 4. If you went right 5 and up 4 again, which I didn't ask you to, but you could, you would end up at 10, 0. So that verifies that that point is correct. I could have just plugged in x equals 0 and x equals, I don't know, 25 or 24 and found respective y values and plotted the points. But you have to have the capability of getting a graph by some method. We're giving you multiple methods. All right. So that will, actually, no, I'm sorry. We have one more tiny little bit of information. There are special cases of lines. Horizontal and vertical lines, we mentioned, have special slopes of 0 and undefined. Horizontal lines have a slope of 0. Vertical lines have a slope of undefined. And that was discussed in the last lecture. Again, horizontal lines have a slope of 0. Vertical lines have an undefined slope. And that's because as you move right, if you're not moving up or down, you can move right whatever number and up or down 0. That means the top number is 0, slope 0. That's the horizontal rationalization. So horizontal and vertical lines are of a special form. They're either just y equals a number or x equals a number. Specifically, and it feels backwards at first, but there's a reason to it. Horizontals are y equals a number. Verticals are x equals a number. The point here is that you're missing a variable. You are missing a variable. It means that there's no dependency on either the horizontal position or instead the vertical position. So it's just saying that the y is always this number. Y represents a height. So if your y is 5, that says the height is always 5, and a constant height is a horizontal line. Or if you have x equals, say, 2, that says you're always going right 2 no matter what the vertical position is. And if you're always going right 2, if you connected a bunch of dots that were just right 2, you'd end up making a vertical line. So I don't have an example 5 typed up here, but I do have an example 5. A, let's graph y equals -3. And we'll just put both of these on the same screen. B, we're gonna have x is equal to 6. Both of these equations are missing variables that makes them special cases. You can't necessarily plug in X or Y values. Only one of them works, and it depends on which one you're in. You can only plug Y values into A because there's only a Y. There's nowhere to plug. I'm sorry, you can't plug in Y values because this says that Y is -3 no matter what. So you could try and plug in X values, but there's nowhere for them to go. So if you try and plug in X equals 10, the Y is -3. If you try and plug in X equals 0, the Y is -3. If you try and plug in X equals 2 million, the Y is -3. And then you can connect those points and extend them. Or you can just have this memorized that Y equals is a horizontal line, and that -3 tells us the height. So here's our X and Y axes. 1, 2, 3, 4, 5. I'll just go down to -5. And again, I'm not going to label every single one of these so I don't squish things together. Y equals -3 would be this specific height. That's our equation of a line. That's our graph of a line, excuse me. This is a height of -3 right here. That's 0, -3. This right here, maybe that's 2, -3. Here's 5, -3. Here's a billion, -3. They're all the same height of -3. Conversely, with B, with X equals 6, that would be a vertical line because it's X equals. And I know, like I said earlier, it feels backwards because X is the horizontal axis. So you might think that X equals 6 means, oh, just go right 6. But again, no, we're saying that you're always going right 6, no matter what the height is, no matter what the Y is. If Y is 0, we're going right 6. If Y is 12, we're going right 6. If Y is 10 billion.3, we're going right 6. So we're going to draw our axes. And X equals 6. So 1, 2, 3, 4, 5, 6, 7. I'm going to label a 7 and the 5 because I'm going to end up cutting through this. Well, I'll switch the color. How about that? We'll do this red. Graph is red. So a vertical line that goes right 6. Trying to be as neat as I can. And there we go. And I didn't put, I guess I did. I did put arrows on the other one. So these are our special cases. Now they have to be solved. If this said 2y equals -3, we would have to divide by 2. If this said x plus 7 equals 6, we'd have to subtract 6 on both sides. They have to be solved to be able to tell their position. And that will close out 2.3. So in 2.3, we talked about how to find slope based on 2 points. We talked about how to find an equation of a line given either a point and a slope or 2 points. And we talked about the multiple ways to graph lines, as well as some special cases of lines. In 2.4, we're going to talk more about slope. More on slope, specifically talking about parallel and perpendicular lines, at least at first. So parallel lines are two lines that never intersect. Again, parallel lines are two lines that never intersect. So if I just, here's a line, here's another line, put arrows on the ends. Those would be parallel. And you'll have a symbol for this that you might see sometimes. It looks like 11. The symbol for parallel lines is 11. It's not actually the number 11, it just looks like it. Perpendicular lines meet at right angles. So a perpendicular line, a pair of perpendicular lines, excuse me. I gotta do this as best as I can. That's not too bad. That's not too bad. Perpendicular lines meet at a right angle. And the symbol for that is an upside down T. Because an upside down T, they're meeting at right angles there. I mean, why not make it a right side up T? I mean, you could argue that. It's just that's what someone decided to do, so it's not confusing. Oh, a T. So if we were in class, I would use these symbols on the board pretty regularly, but all right. So how does this relate numerically? How do we relate the slopes of these two things to each other, two parallel lines or two perpendicular lines? Well, parallel lines have slopes that are equivalent. M2 is equal to M1, and those are supposed to be subnotations. So I'm going to write over here what it should actually look like. M little 2 is equal to M little 1. In other words, if you know the slope of the first line, the second line is the exact same number. If slope 1 is 3 and the other is parallel, slope 2 is 3. Perpendicular lines have negative reciprocal slopes, which means you flip it and you change its sign. So M little 2, and I'll write this as a better fraction, is negative 1 over M1. Again, you flip and change the sign. Because now what we're going to start doing is giving you, like example 1 and 2, an equation of a line, and then ask you to make another one that's either parallel or perpendicular to it. So let's knock out example 1. Write the equation of a line going through 1, 4 and parallel to y equals 5x plus 800. And we want to ultimately write this in slope-intercept form. I'm skipping the graphing this time. So all we want is the equation. And we want this to be solved for y because I asked for it in slope-intercept form. So our point is 1, 4. And then another line involved in this whole thing is y equals 5x plus 800. All right, so whiteboard. New page. Example 1. This will be A. We have the point 1, 4, and we're going to be parallel, there's my symbol, to y equals 5x plus 800. And you might be thinking, oh, 800, that's a big number. That's going to make things really complicated and annoying. Spoilers, no, it won't. So what exactly do we need to write an equation of a line? We need a point and a slope. That way we can put it in point-slope form. Well, I gave you a point, but I didn't give you a slope, at least not directly. I gave it to you implicitly. And by implicitly, I mean it's in this information right here. We're supposed to be parallel to this line. So you can call it line 1 or line 2. It doesn't matter what you call it. But let's call it line 1. The line that they gave us. And M1, the slope of that line, since it's solved for y, is the coefficient of x, which is 5. So the slope of the line that we don't even care about necessarily is 5. The only thing we care about is that we need to make a parallel line. Well, if you go back to those previous notes, parallel lines have equal slope. So M2 should be the exact same thing as M1. So the slope of the line we need to make, our goal is line 2, is also 5. Now, here's what I would do when I'm working on a homework problem or a test problem. Now, I don't necessarily want you to do this on your own at this moment, but this line right here, I don't want to look at it anymore. It's gone. Pretend it's not there, because we don't care about that line where it is. We just cared about its slope so that we could get the slope that we need. This is our slope. So we need to be using this slope along with this point. I wish I hadn't written that in black. Like I said, I don't want to completely scribble that out, but that's what you should be mentally doing, pretending that's not there anymore. So this is our slope. So we need to use that slope and that point into the y minus y1 equals m times x minus x1 format. So y minus y1, that's going to be 4, equals the m, which is 5, times x minus x1, which is the 1. And then we need to solve this for y. So we'll distribute the 5, make sure my y looks like a y. Y minus 4 equals 5x minus 5. We're then going to add 4 to both sides, which is going to give us y equals 5x minus 1. And that is our equation in slope-intercept form. So the slope is still 5, the b is -1, so the y-intercept is -1. I didn't ask you to identify all that information for the particular example, but it's important that you still understand that. I also did not ask for the graph, so I'm not going to graph this one, but if you need practice, go and do that. You can plot the 1, 4. You could also then plot the 0, -1, and you're done. Or you can plot the 1, 4 and go right 1, up 5, and you would get your second point. You could also plot the intercept, 0, -1, and go right 1, up 5. In fact, you'd pick up the 1, 4 if you did that. All right. B. Now, before that, let's go back to our screen. And it deleted the annotation. That's all right. It's still here, basically. So write the equation of a line going through -2, 3, and be careful here. This is the one that students mess up. They just always want to do parallel. They just always want to make the numbers the same, and half the time that's wrong. Perpendicular. M2 is not M1 here. This is when it's the negative reciprocal, so we're going to be flipping and changing a sign of something here. And we're supposed to be perpendicular to y equals 4x minus 50, 20. So our point's -2, -2, 3, and our equation to be perpendicular to is y equals 4x minus 50, 20. So the point was, again, -2, 3, and we got to be upside down t to the line y equals, what was that, 4x minus 50, 20. Also, the equations of parallel or perpendicular lines don't have to be solved for y. We can give these to you in any format we like, and you would have to know to solve them for y to be able to extract the slope. So just be aware that I don't have to give it to you this cleanly. I'm just trying to emphasize certain points. All right, well, based on that line, M1, if we call this line 1, that slope is the coefficient of the x, which is 4. But we need to make a perpendicular line, so the second slope is the negative reciprocal of the original slope. So the slope of the line that we need, we'll call M2. Now 4 as a fraction is 4/1. I'll show that up here. I got a little extra space. I just got to move something. So 4 is 4/1. And when we do this flip and change sign, the 4 and the 1 become a 1/4. It was positive though, so now it's negative. So that's down here. M2 is now -1/4. And this is the slope that we need. So again, previously we said, don't worry about this line anymore. If you need to erase the M1 as well, do so. But in your own notes, I would not do that because you might look at these a month later and go, well, what happened to everything? So again, mentally, we're blocking this information out now. We don't care about line, I wrote line 2 there. That's supposed to be line 1. We don't care about that information anymore. Let me just correct this. That was supposed to be line 1. So this is line 1, we're making line 2. So what we need to use is the slope of the perpendicular line as well as the point prescribed. Again, we don't need any of the equation from the first line. We don't need the slope of the first line, just the stuff I circled recently. Plugging them into point slope form, we get y minus 3 equals the slope, which is negative 1/4, parentheses, x minus the x1, which is negative 2, so watch out for that negative. And then we just, surprise, surprise, solve for y. That double negative becomes a positive. So y minus 3 equals negative 1/4 x in parentheses plus 2. We're going to distribute. I'm going to put this over here, though, after I distribute, because I'm going to run out of room. So that's going to be y minus 3 equals negative 1/4 x minus a half. And if we were in class, this is where I'd go. Somebody asked me where the minus half came from. And that was from taking the negative 1/4 times the 2. Again, that was taking the negative 1/4 times the 2. Which 2 is 2 over 1. Reducing and multiplying straight across. That becomes a 1 and this becomes a 2. And that's where the negative 1/2 came from. Now, to finish this up, we just have to add 3 to both sides. And what that's going to give us, on the left side, it's just y equals now. On the right side, we got our negative 1/4 x. And then negative 1/2 plus 3 is going to be positive 5/2. And that's our equation of the line. Now, again, if we were in class, this is where I would go. How did we get the 5/2? And that was by adding and subtracting fractions, a technique that I just reminded my developmental class today that they never get to forget. So that little side work, the negative 1/2 plus 3 over 1, the LCD would be 2. So that's going to become negative 1/2 plus 6 over 2, because 1 goes into 2 twice. 2 times 3 is 6. The negative 1/2 stays. Negative 1 plus 6 is 5. So that's 5/2. Again, addition, subtraction, multiplication, division of fractions and decimals is literally never going to go away as long as you're taking math classes, especially pre-calc and up. And yet, they are very often forgotten techniques. So please don't forget them. Please de-rust if you have rusted. So B is definitely one of the more challenging problems initially, but with practice, paying attention, understanding when you make the slopes the same because they're parallel, or when you flip it and change the sign because it's perpendicular. Those are the biggest issues, as well as some fraction stuff. Now, if you wrote these as decimals, as long as they were terminating decimals, like 5/2 is 2.5, then my math lab shouldn't care, nor would I. But if you had a fraction of, say, a third, which is 0.3 bar, if you just write 0.3 or 0.33 or even a 3 10 million times without the bar, that's incorrect. And my math lab would mark it wrong, and I wouldn't accept it. All right, so this is how we can build an equation of a line based off of another line, based off of a parallel or perpendicular line. Let's go back. Oh, that's right, I had an example 3. I almost forgot. Example 3, means write the equation of a line going through. This time our point is 5, 8, and we're going to be perpendicular to x equals 11. Huh, well, that's weird, right? That's what everybody's thinking initially, because that's one of those special case lines. This is kind of a special case problem because of that. if you're dealing with parallel or perpendicular to a horizontal or vertical line, you need to understand whether the original line was horizontal or vertical. So points 5, 8, and then that's x equals 11, and we're supposed to be perpendicular. 5, 8, perpendicular, x equals 11. Again, 5, 8, perpendicular to x equals 11. And this was example 3. So we're going through the point 5, 8, and perpendicular to x equals 11. So x equals 11 is a line. That's our line 1. You have to understand that since a variable is missing, it's a special case. It's either horizontal or vertical. X equals happen to be, that's right, vertical. So line 1 is vertical. Now, it might actually help you to draw up this line. It might not, but it can rationalize things a little better. That vertical line, if I just put a hash mark over here and call it 11, this is the line x equals 11. Now, if, I'm saying if here, this is not what the problem is. If the instruction said we needed to make a parallel line, which is not what it said. If we needed to make a parallel line, since this is vertical, we would have to make another vertical line somewhere. It's just a matter of where. Now, because that would be vertical, we'd have to make another x equals equation. But it's not. We were told to make a perpendicular line, and perpendicular to vertical lines are horizontal. Ooh, that was weird. Horizontal lines are perpendicular to vertical lines. So we need a horizontal line, which means the form has to be y equals a number. If we were making a vertical line, we'd make another x equals a number, but we need y equals a number. Now, this line is supposed to go through the point 5, 8, and again, technically you don't have to do any of this graphing, but it might help you. So 5, 8, where exactly is that point? I'm gonna use a different color for this. Let's go with blue. 5, 8. So that's right 5, I'll just call this 5, and up 8. We'll call this 8. So here's 5, 8. That's the point we have to go through. Now, if we were parallel, I would just draw a vertical blue line here, but it said perpendicular, so I'm drawing a horizontal blue line. So that blue line is our equation. Now that's a horizontal line, so it has to be y equals a number, and the number has to be the height, and the height is the 8. So to match the height of the requested point, y has to be equal to 8. Guess what? If we'd asked for a perpendicular line going through that blue dot, here's where your vertical line would be. It's going through x equals 5. So the answer would be x equals 5. Look at these numbers here, 5 and 8. It is not a coincidence that the horizontal line going through that point is y equals 8, and the vertical line is x equals 5. It's just a matter of picking the right one. So if you wanted to skip all this drawing stuff, what you can actually do is just say, oh, all right, well, since it needs to be y equals a number, take the y value of the point, y equals 8. If I had needed to make a vertical line there because of it being perpendicular, vertical lines are x equals a number, so we take the x coordinate, which would have been x equals 5. So I basically talked through an example 3b, if you will. I just didn't show the work, but I did talk through every detail of it. So again, how you go about doing this is up to you, whether you graph the original line, do a point, show the parallel or perpendicular one, then build the equation, or if you just understand that an x equals has to take on an x value of a point and a y equals has to take on a y value of a point, that'll get the job done quicker. And I could even ask an extra question is, what is the slope of this line? And since it's horizontal, its slope would be 0. And in particular, the original line, since it was vertical, oops, its slope would be undefined. But you can't use undefined in the point slope form because undefined isn't a number. So that's why I didn't plug this into y minus y1 or anything like that. Because if you try to plug undefined in, the whole equation just turns into nonsense. All right. So that's example 3. Now we're down here. And you can see the typed up explanation I had here as well. Slope as a rate of change. There are a lot of phrases to describe slope. And a new one, for us probably, is rate of change. Rate has a relationship to the word ratio. Ratio means fraction. So the word rate means fraction. Change is generally a difference, an old and a new being subtracted, new minus old. So a rate of change is a fraction of subtractions. Again, a rate of change is a fraction of subtractions. That sounds a little funky, but just bear with me. Slope is a rate of change. Slope is a rate of change. If you don't believe me, go back to the slope formula. Again, what was our slope formula in the past? M equals y2 minus y1 over x2 minus x1. It's a rate because it's a fraction. The top is a change because it's a difference. The bottom is a change because it's a difference. This is a rate of change. So it's just another phrase. Slope is the same thing as saying rate of change. To calculate the rate of change for a function at 2 different x values. So we've been using this slope formula for just equations, things that were written in x and y's. But back earlier in the chapter, we introduced function notation and we described how useful functions are because we can do things with them that we can't do with equations necessarily. So what's the main difference between equations and functions? It's that you write f of x instead of a y. So first, you have to find the respective y values. So no longer are we going to give you both the x and the y values. You're generally just going to be given the x values for these types of problems. But you can find the y values by plugging them in, the same as an equation. Functions, you just plug an x value in to find a y value in. So we'll only give you x values. You'll plug them in to find the y values, to find the function values, if you prefer saying. And then you're going to use the formula. And I want to put this on the whiteboard. And we call this the average rate of change. For f of x. So again, given an x1 and an x2, your average rate of change is going to be f of x2 minus f of x1 all over x2 minus x1. That's our average rate of change formula. And for some reason, it just feels very familiar to me. So rate of change. Well, it's a rate because it's a fraction. And the top is a change and the bottom is a change because they're differences. So this is the average rate of change of a function from point 1 to point 2. I'm not saying that the slope is this specific number. I'm saying that the average slope is this number because functions are not necessarily linear. Lines have constant slope. Functions and curves do not necessarily have constant slope. But this would give you the average slope from point 1 to point 2. Notice the similarities to the slope formula, which was m equals y2 minus y1. It's about the 5th time we've written it together, over x2 minus x1. The denominator, the bottom, is literally the exact same thing. It's the run. The top is still the rise. It's just instead of using y2 minus y1, instead of using y's, we're using function notation, which is the f of x's. So again, that's f of x2 minus f of x1. The 2's and the 1's are consistent. So this is a formula that you have to memorize, but in principle, it is the exact same formula as slope. It just uses function notation instead of y's, which enables us to talk about a rate of change for something that's not constant. It just gives us an average. And the whole concept of calculus begins with taking this average rate of change, having 2 separate points, and just merging them into 1 point, squishing them together. And guess what? That difference quotient with the h in the bottom, that's exactly what this thing turns into. And you'll see that in calculus. All right, I think I had the problems typed up here. Yes. And again, these little 1's and 2's after the x's are supposed to be subnotation. This caret with a 2 means x squared. You'll see them written correctly on the whiteboard, thankfully. So for example, 4a, we're going to find the average rate of change, the AROC, for the function x squared plus 5x minus 10 between x values of 0 and 4. So we're trying to find the average slope from x values of 0 and 4. All right, back to our whiteboard. And I can fit this up here. Too many pop-up menus. Come on, go away. Example 4a, our function was x squared plus 5x minus 10. And we got an x1 of 0 and an x2 of 4, I believe. So we are not finding the slope of this function. We're finding the average slope specifically from 0 to 4. And if I pick any other 2 numbers, the average slope is likely to be different. Okay, so the first thing we have to do is plug in the x values. So many people forget to do this. So f of x1, that's the same thing as finding f of 0. So just go to the x squared plus 5x minus 10 and turn the x's into zeros. So that's going to be 0 squared plus 5 times 0 minus 10. That's 0 plus 0 minus 10, which is negative 10. So this is y1, basically. This is f of x1 or y1. They are the same things, basically. So I even write it over here just to be careful. That is your f of x1. F of x2, well, x2 is 4. So that's f of 4, which is 4 squared plus 5 times 4 minus 10. That's 16 plus 20, which would be 36. And then 36 minus 10 would be 26. That's our y2 or f of x2, no matter which one you want to call it. It's the same value. And then we're just doing our slope. You can even write these as points now if you want. You don't have to, but your points are now 0, negative 10, and 4, 26. I find that most people don't write the points. It's up to you. If you need to write them, write them. If you don't, you don't. What's important is that you can plug everything into the formula appropriately. So your average rate of change. Again, basically y2 minus y1 over x2 minus x1. We're just using function notation. So our y2 is f of x2, and that was the 26, minus the y1 is the f of x1, which is negative 10. That's a double negative, all over. Then x2 minus x1, those were given to us, 4 minus 0. I have to give you x values. You can't do this without x values, but I no longer have to give you y values. Well, that's going to become 26 plus 10 over 4 minus 0. Yes, you could have gone ahead and subtracted the bottom. 26 plus 10 is going to be 36. 4 minus 0 is 4. And 36 divided by 4 reduces to 9. So that says that the average slope of this function from 0 to 4 is 9. I'm not saying that the slope at 0 is 9. I'm not saying that the slope at 4 is 9. I'm not saying that the slope anywhere is 9 in particular. Now, it is actually true that the slope somewhere has to be 9, but we won't get into that in here. That's a calculus idea. So the average slope is 9. Okay. B. Actually, hold on. Does the x1 and x2 matter in which one comes first? No. So if you wanted to swap what you call x1 and x2, you can. I can call x1 4 and I can call x2 0. Or you can say that I just want to do 1s minus 2s down here. So you could do negative 10 minus 26 and 0 minus 4. Negative 10 minus 26 is negative 36. 0 minus 4 is negative 4. And guess what? Negative 36 divided by negative 4 is still positive 9. It's that you're consistent is all that matters. Thank you for asking. All right. B, and this function is a little more interesting. This is what we call a rational function. So that x plus 3 is supposed to be on top of the x minus 5. And we're going to go from a first point of x equals 2 to a second point of x equals 10. So again, I'm going to rewrite this more appropriately on the whiteboard. Word was just giving me a bit of trouble with the math editor. I think it's because of the computer I'm on. So x plus 3 over x minus 5 between points of 2 and 10 in the x values. All right. Next page. So this is example B. So our function is x plus 3 over x minus 5. Yes. And we're going from x1 was 2 and x2 is 10. And we're finding the average rate of change from x's of 2 to 10. If I did from 1 to 10, different answer. If I did from 0 to 10, different answer. If I did from 0 to a million, different answer. If I did from 2 to 3, be a different answer. So first thing we got to do is find f of x1 and f of x2. F of x1 is the f of 2, which is 2 plus 3 over 2 minus 5. And this problem's probably going to annoy you a little bit because of all the fractions, but such is life. 2 plus 3 is 5. 2 minus 5 is negative 3, but you know I don't like negatives left in the bottom, so let's put it in the top or the front. So that's negative 5 thirds. Went a little crazy with the negative, but that's negative 5 thirds. That is the f of x1. F of the second point's 10, so f of 10. That is the x value is 10. So that would be 10 plus 3 over 10 minus 5. 10 plus 3 is 13. 10 minus 5 is 5. And that's irreducible. So that's our f of x2. Now, you could convert 13/5 to a decimal pretty cleanly, but you can't convert negative 5 thirds to a decimal. And if you're using calculators when you shouldn't be, you're going to get some ugly decimal number for this, which is then going to make the answer kind of wicked. And I'm going to know exactly what you did. So even though you might be using calculators when you shouldn't be, it's still going to come back to haunt you if you're not capable of your math with fractions. So then our average rate of change from 2 to 10 specifically, that's the difference of the function values over the difference of the x values. the function values being the 13/5 and the -5/3. I'm going to be consistent and go second minus first. So 13/5 minus parentheses -5/3. That's the f of x2 minus f of x1 all over x2 minus x1. That's 10 minus 2. I'm going to go ahead and fix up that double negative. So that's 13 over 5 plus 5 over 3, then all over 10 minus 2. And I'm going to do something extra as well here. I'm going to write that 10 as 10 over 1, and this 2 is 2 over 1, because we had fractions inside of fractions. These are known as compound fractions, or a little more inappropriately named, in my opinion. Some people call them complex fractions, like our textbook. I don't like calling complex because there's no i's, as you've heard me rant before. But anyways, fractions inside of fractions are not allowed. We want to get rid of all these extra denominators by finding an LCD and multiplying all the tops by that. This is a technique from the prereq material. So our LCD with denominators of 5, 3, and 1 is 15. And that's what we multiply all tops by. The 13, the 5, the 10, and the 2 specifically. So I'm going to show that with a different color. Yeah, we'll do that. So 15 times the first fraction plus 15 times the second fraction, then all over 15 times the third fraction and 15 times the fourth fraction. So the first fraction was 13 over 5 plus 15 times 5 over 3 all over 15 times 10 over 1 minus 15 times 2 over 1. I didn't have to write those denominators of ones, but I find that it's helpful for some people, so I did it anyways. And then all of these fractions are now reducible. The individual fractions, that is. 5 is going to go into 15 3 times. 3 is going to go into 15 5 times. 1 is going to go into anything. So now those individual fractions are all gone. So this is really, and I'll leave the products just to make sure everybody's on the same page. 3 times 13 plus 5 times 5 all over 15 times 10 minus 15 times 2. Please do not reduce this way. The plus and the minus make this irreducible unless that factor is everywhere, and that's not happening here. 3 times 13 is 39. 5 times 5 is 25. All over 15 times 10 is 25 minus 15 times 2 is 30. Then 39 plus 25 is going to give us 64. 25 minus 30 is going to give us -5. What did I do wrong here? I feel like I did something wrong. 15 times, oh geez, did I say 15 times 10 is 25? Yep, y'all caught me. Thank you. 15 times 10 is not 25, obviously. It's like something's looking weird here. 15 times 10 is 150. Sorry about that. And then 150 minus 30 is going to give us 120. I honestly don't know where that 25, oh, I know why. I was looking at the 5 times 5. Reading, writing, and talking at 3 different speeds is always fun. Okay, now that we got my error out of the way, we got 64 over 120, but this is a reducible fraction. 8 is going to go into both of these. 8 will go into 64 8 times. 8 will go into 120 15 times. 8/15 is irreducible. So that is our average rate of change. Yeah, when I saw that the bottom was negative, I was like, I don't think I had a negative for this. Something went wrong, and you all caught me at the same time. So cool, we're all on the same page. So with that in mind, let me just rediscuss this problem and what we did, because it was a little more complicated. And we are getting close to time, so this will probably be our last for the day. No, we can knock out the next one. The next one's short. So we had our function with its x values. We plugged those in to find the y values, aka the function values. We then plugged those four numbers into the average rate of change formula. F of x2 minus f of x1, also known as y2 minus y1, over x2 minus x1. But this problem was much more of a nuisance than previously because there were fractions, so we had to find an LCD and then get rid of all those compound fractions. Now there is another way to have done this. You could have combined the tops and the bottoms. By tops and bottoms, I mean across the big division. And then you'd end up with a fraction divided by another fraction, and you can multiply by the reciprocal. That works as well. We cleaned everything up. We watched our arithmetic and how we're thinking and writing at different speeds. We fixed our error. We reduced our fraction, and we got our 8/15. All right, so let's do this last one with our remaining 5 minutes. And I won't flip to the screen. I'll just tell you what it is. For C, the function is x cubed plus 1. And we're going to go from x1 equals -2 to x2 equals +2. And when we do D next time, it's going to have some similarities but drastic differences to this problem. Okay, so f of x1, which is f of -2. Now, because I'm plugging in a negative, we need a parentheses. -2 cubed plus 1. A negative to an odd number is a negative. 2 cubed is 8, so that's -8 plus 1, which is -7. Our f of x2 is f of +2, which is 2 cubed plus 1, which is +8 plus 1, and that's 9. So the -7 was our f of x1. The 9 is our f of x2. Again, comparatively, y1 and y2. But the good thing is with function notation, we could be plugging in things that aren't numbers. I can plug in a z or an h or an x plus h that would lead us to calculus stuff. All right, so our average rate of change from -2 to +2 specifically. F of x2 minus f of x1 is 9 minus -7. That's the outputs over the inputs. 2 minus -2. We got a whole bunch of double negatives, so that's 9 plus 7 over 2 plus 2, which is 16 over 4, which is +4. Again, all this was finding a slope, but you had to find the y values first. We don't give you y values of functions generally. I don't even have to give you y values of lines. I can just give you an equation of a line. I can give you y equals 2x plus 3 and say find the slope from x equals 0 to x equals 5. And it's literally what we just did. There's nothing different there. So I have one more example to cover next time. So I would say pretty much 2.4 is done. Our homework is due on test dates anyway, so it doesn't technically matter. So we will do one more problem from 2.4, and then we'll dive right into 2.5, transformations of functions, next class on Tuesday. So if you had any questions about your test, if you had maybe an answer that it looks like there was a typo, in particular with your quadratic formulas, if you used a plus or minus symbol, I know at least one student, it marked it wrong, even though technically it's correct. I'll go back and give credit for something like that. And the results were pretty good. I saw lots of A's and B's. So again, that's good. If you didn't take your test, unfortunately, the time is up. So just make sure that you do excellent on the next test. But that's the format I'm thinking of keeping things for now. If I need to change it for some reason, I will, of course, let you know. The next test on Chapter 2, we've got a little bit of time until we get there anyways. How quick am I responding during the weekend. I can't promise anything necessarily because I'm not always here. If I have the capability to read your email and answer your question, then I will, but I'm mobile a lot. So I'll get back to you as soon as possible. Okay, I see your comment, Kate's. Shoot me another email just to be safe. I don't remember seeing an email from you. And I'm getting a whole lot of emails now, so it's possible I clicked it and then just didn't even see it. So, and per usual, if I don't get back to you within 24 business hours, email me again and just say, hey, what's the status on this? Because I may have read it and forgot to respond because I was busy, or I may have just missed it entirely because, like I said, the number of emails I'm getting is probably multiplied by 10 with this new format. Again, have a great weekend. Get some homework done, stay on top of things. Let's all do as best as we can given the situation. I know I am, and I hope I'm doing my best for you. So we'll call it a day there. This video will be uploaded to YouTube, hopefully within a half hour in case you missed anything or need to replay anything. Take it easy, everyone.